Looks like pretty good now. I don't know which side I want to see. This one. Okay. So watch carefully. And let's see if we can get a good sense for whether or not there is a constant velocity while I'm pushing it, while it's traveling along this part, while it interacts with the crack, while it travels along that part, and while it stops.
It does slow down.
Seems the faster you're going, the less noticeable the slowing down is. Does it mean it's not slowing down?
Maybe does that mean it interacts for a longer time?
Yeah, that's
Very
right.
much.
So it's going to interacts for longer, and so it slows down more?
Yeah.
Interesting. Okay. So what do we observe in terms of what's happening to the velocity in those three moments? When I'm touching it, when the crack's touching it, and when it's touching it?
Then you touch it accelerates, and then it decelerates, and then it decelerates again.
So the velocity is not constant. It's either getting larger or small, or all the way small. Okay, let's put it back in, and let's get that kind of wrapped up, and let's go on to the more interesting here. Okay. So would you all agree then that during these three parts of the motion, it is not a constant velocity? Do we have enough of a correlation, a trend, to start to build a model on here? Do you see a pattern here that we can use as the basis for building a model?
Yeah.
What is that pattern, Becky?
When you would first start, when you would first start trying to reach, I guess, to that constant velocity, and then it reaches the constant velocity, it's a straight line. And then because the bump slows down the velocity,
Okay.
it would go a negative way. So it's supposed to be negative, and then it would reach the constant velocity point.
So when you heard me say build model, you interpreted that as draw velocity time graph. Yes? That's cool, that's a good thing to do. It'll help us represent, it isn't the model, it'll help us represent it. So you're going to say, let's describe what's going on in terms of velocity time graph. I think you described it basically looking like something like this, and then I interrupted you.
And then the ending would just be like, I don't know what the ending is.
So it goes down one more time. Down to 0.
Zero. So then, there's my green parts, and there's my brown parts. Is that right? Okay. Okay. So another representation, we have kind of two representations of the information we've gathered of our data. Can we take that information, given that our stated goal is to find some kind of correlation between interactions and type of motion? Do we see any kind of pattern that we can identify that might help us move forward with building a model? Okay.
At times there's no interaction, basically.
I'm sorry, louder, please.
Whenever there's not interaction, that means it has a constant velocity, whereas if something interacts with it, it doesn't have a constant velocity. That can help build a model in some way.
Okay, so you are noticing that when there's, let me say that, it says that when there's not interaction,
It has a constant velocity.
it has a constant velocity,
There's not a constant velocity.
but when there is an interaction, there's not a constant velocity. Do you all buy that? Is that what you see? Yes, okay. So could we take that as the beginning of a tentative model for predicting when you'll have a constant velocity and when you won't? Yeah, okay, great. Let's introduce a few more scenarios and test that in some more scenarios and see how it works. And the scenario I'm going to do next is, I want to extend this notion of interaction to the possibility of an interaction that keeps interacting. Because all the interactions so far are ones that were just momentary. We had a momentary interaction with my hand, with Emitam's hand, with the crack in the table. Can this same set of patterns still apply if we have an interaction that is continuous? That we keep interacting with it. If I walk along with the ice and keep pushing it. Now, opens a question, how do I tell if I'm interacting with it?
The velocity changes. So far, like, from what we've had so far, you can tell you're asking that it's not a constant velocity.
If we assume our model's good and has extended applicability, we can make that inference. But that would be an inference, not an observation. If we're trying to test the model, we'd like to be able to also directly observe whether or not we're interacting with it. Does the fact that my hand is next to it mean I'm interacting with it? Does it mean- Can I be next to it without actually having an effect on it? Okay. So, would you call that an interaction? Would you call that interaction? And yet you can really, the only way you could tell the difference is by looking at the expression on my face. Right? You can't really see that I'm doing anything different. So how can we tell whether or not I'm actually interacting when my physical location has to change? I'm going to introduce a little tool here. I need one more volunteer. All right, Scott, you're going to put your finger out, okay? You're going to curl around to hold that up. There you go, okay. You're going to close your eyes, okay? And you're going to report back to the class what you feel, kind of in real time, just kind of keep talking.
Okay.
Okay? And you all are going to watch what you see and correlate it to what you feel.
The rubber band's like pulling back, and there's more tension in between, and it's pulling back farther,
And
and
when you say farther,
it's
do you feel farther?
no, I feel like there's more tension on my finger,
Okay.
and more, and there's still a lot of tension right now. And there's no tension at all.
Is it still touching you?
Yeah, it's still touching me.
But not really interacting with itself?
No.
Okay. How about now?
There's a lot of interaction right now.
Now?
Yeah.
Now?
Yep. Still some. Let's go. It's
Okay, let's rate on a scale of 1 to 10.
7, 4, 2, 0, 7, 5, 3, 6.
All right, thank you. Okay, you can open your eyes. All right. Who can explain the pattern they saw in his answers and what you were able to notice with your eyes? Brian?
The more tension you put on the rubber band, the more interaction you have.
Okay, now the tension, is that an
Like
observation?
the farther you pull the rubber band away from his hand, the more interaction you got occurring.
Okay, listen.
Well, I actually have a question. So let's say I was pushing this desk, no matter like how hard I push this desk, I heard somewhere that like I'm never really touching the desk. There's always like some kind of space.
Let's not try to get into that right now. That's based on atomic models of matter.
Okay.
And for our purposes, it's going to be perfectly sufficient to model this desk as a thing you can touch.
Okay.
Okay. But back to this question, what's the pattern we see? There, the strength of the interaction can be visibly observed by watching what? Sorry?
Your movement of the rubber band.
Can be more specific. What does it look like when there's a strong interaction? It's longer. Okay, so would this be a strong interaction?
Yeah.
Okay, and how about, would that mean a strong interaction? So it's not movement, because that's movement, right? So what is this?
When it's
Well,
relaxed,
whether it's
stretching,
movement or
relaxing.
So how relaxed versus how stretched it is, right? Interaction now? Not really, right? And now?
Yes.
And now?
Yes.
And now? Okay, let's apply that, because now we have a way of telling when I'm interacting with dry ice and when I'm not, and so I can ensure that I keep interacting with it and see what happens. Gloves. Probably should have kept that on. Wait for it to cool down. What? This is so I have something to attach the rubber band to. Alright. Okay, I am going to attempt to continue to interact with this dry ice as I go along the table, rather than stopping interacting with it right away. I want you to observe the rubber band and tell me how successful I am in that attempt. I think it's shining blue light. Oh, right. Okay. Was I successful? Did I continue to interact with it? Tell me when the interaction ceases. Give me like a loud now. And it's game.
Now.
Okay. Now. And how do you know?
Is the rubber band flat, like out.
One slack. Okay. Okay. So we're aiming at not doing that. Let me try again. How was that?
That was good. It was good.
That's pretty good?
Yeah.
Okay.
You increase your speed.
How was that? That was good. Okay. Go this way. So, what motion do you observe? What was it? It looked like it was accelerating. How can you tell that?
Because,
Five.
so it would relax, so when you're relaxed, you have to increase your speed.
You'll be about watching.
You had to go
the-
to-
Okay. Oh, one at a time. You finish.
Okay, when it was about, in order to not reach your constant velocity and stay there, you have to increase the speed at which you were pulling it, so.
Did I increase how hard? Did I increase the interaction?
No, just your speed going down that way.
Okay. Scott.
You had to increase the interaction between your finger and the rubber band to go in fact to keep it at a constant velocity. Or
So at the crack, I had to increase.
yeah,